Picture this. You're standing outside on a clear night, gazing up at the river of stars we call the Milky Way. Those billions of lights represent our cosmic neighborhood, a spiral galaxy 100,000 light-years across. But here's something that might shake you to your core. Humanity, with all our dreams of exploring the cosmos, might be forever trapped within this single galaxy. Not by choice, but by the fundamental laws of physics themselves. Today, we're confronting a truth that science is only beginning to fully grasp. If you're fascinated by humanity's cosmic limitations and want to explore more mind-bending realities about our universe, make sure to subscribe to this channel and give a thumbs up. Let's start with the sheer, incomprehensible scale we're dealing with. The Milky Way contains between 200 and 400 billion stars. If you started counting them at 1 per second, it would take you over 12,000 years to count them all. But here's what's truly staggering. Our galaxy is just one among 2 trillion galaxies in the observable universe. The nearest major galaxy, Andromeda, sits 2.5 million light-years away. That means the light you see from Andromeda tonight left when our ancestors were just beginning to use stone tools. To understand why we might never escape, we need to grasp what a light-year really means. Light, the fastest thing in the universe, travels at 300,000 kilometers per second. In 1 year, it covers nearly 10 trillion kilometers. The Voyager 1 spacecraft, humanity's most distant object, has been traveling for 47 years and has only covered about 0.002 light-years. At its current speed of 17 kilometers per second, it would take 73,000 years just to reach the nearest star, Proxima Centauri, which is still within our galaxy. But escaping the Milky Way isn't like leaving Earth or even our solar system. The edge of our galaxy's gravitational influence extends far beyond the visible disk of stars. The dark matter halo surrounding our galaxy reaches out perhaps 300,000 light-years from the center. To truly escape, we'd need to overcome not just distance, but the combined gravitational pull of hundreds of billions of stars, plus 6 times that mass in invisible dark matter. The energy requirements are where physics becomes our prison warden. To accelerate a single kilogram to just 10% of light speed would require energy equivalent to the entire annual energy consumption of the United States. To reach speeds necessary for intergalactic travel within human lifetimes, say 99% of light speed, you'd need more energy than our sun produces in a year, and that's just for 1 kilogram. A practical spacecraft would weigh thousands of tons. Now here's where it gets even more daunting. The universe isn't static, it's expanding, and that expansion is accelerating. Edwin Hubble discovered this in 1929, but the real shock came in 1998 when astronomers studying distant supernovae realized the expansion was speeding up. Dark energy, a mysterious force that makes up 68% of the universe, is pushing galaxies apart faster and faster. Galaxies beyond a certain distance are already receding from us faster than light, not because they're moving through space that fast, but because space itself is expanding between us. This creates what's called the cosmic event horizon. Right now, galaxies more than 16 billion light-years away are already unreachable. Even if we could travel at light speed starting today, we'd never catch them because the space between us is expanding too quickly. Every second that passes, more galaxies cross this horizon, becoming forever unreachable. By the time we develop any technology capable of intergalactic travel, most of the universe will have disappeared beyond this cosmic boundary. The local group, our cluster of about 80 galaxies, including the Milky Way and Andromeda, is gravitationally bound together. These galaxies won't fly apart from cosmic expansion. Gravity holds them. But beyond our local group, which spans about 10 million light-years, Every other galaxy cluster is racing away from us. The Virgo cluster, our nearest large galactic neighbor at 54 million light-years, is receding at over 1,000 kilometers per second due to cosmic expansion. Consider the timescales involved. If we develop technology to travel at 1% of light speed, which would be a miraculous achievement, a journey to Andromeda would still take 250 million years. That's longer than the time since dinosaurs appeared on Earth. By the time such a journey ended, our sun will have significantly aged, Earth might be uninhabitable, and humanity as we know it would likely have evolved into something unrecognizable or gone extinct. The relativistic effects add another layer of complexity. As you approach light speed, time dilation becomes extreme. Travelers might experience the journey to another galaxy in just decades from their perspective, but millions of years would pass on Earth. They wouldn't be escaping to explore, they'd be abandoning humanity forever, arriving at their destination to find their entire species either extinct or evolved beyond recognition. It's not really escape if you can never return or even communicate with home. Let me paint you a picture of our current propulsion reality. Chemical rockets, like those that took us to the moon, max out at about 17 kilometers per second. Ion drives, our most efficient current technology, can achieve speeds up to 90 kilometers per second, but with thrusts so gentle it takes years to build up speed. Even theoretical fusion rockets might only reach 3 to 5% of light speed. We're talking about technologies that don't yet exist, achieving speeds that are still woefully inadequate for intergalactic travel. The breakthrough Starshot initiative, announced by Stephen Hawking and Yuri Milner in 2016, represents our most ambitious attempt to reach even the nearest star. Using powerful lasers to push tiny light sails, these gram-scale probes might achieve 20% light speed. But here's the reality check. This would only get us to Proxima Centauri in 20 years, and that's still within our galaxy. Scaling this technology to carry humans or reach other galaxies would require laser arrays larger than Earth and energy outputs exceeding our entire civilization's capacity. Speaking of understanding our cosmic prison, if you want to grasp the true scale of what we're trapped within, check out my video We Just Found Out How Big the Milky Way Is, where I explore the mind-blowing discoveries about our galaxy's actual size. The link is in the description below and pinned on the comments. Now back to why we might never leave it. Nuclear pulse propulsion, studied in Project Orion during the 1950s and 60s, could theoretically achieve 3 to 5% light speed by riding the shockwaves of nuclear explosions. Project Daedalus, a 1970s British study, designed an unmanned probe using fusion that might reach 12% light speed. But even these speculative technologies would take tens of thousands of years to reach the nearest galaxy. And they require technologies we don't have, using resources we can't access, with engineering challenges that might be insurmountable. The Great Filter hypothesis adds a chilling dimension to this discussion. Perhaps the reason we see no evidence of intergalactic civilizations isn't that life is rare, but that escaping one's home galaxy is literally impossible. Every intelligent species in the universe might be trapped in their own galactic islands, forever separated by expanding voids of space. The eerie silence of the cosmos might not be because we're alone, but because everyone is imprisoned by the same laws of physics. Dark matter complicates everything further. Our galaxy is surrounded by an invisible halo of dark matter that outweighs visible matter by 6 to 1. This creates a gravitational well far deeper than what we see from stars alone. To escape the Milky Way, we wouldn't just need to reach escape velocity from visible matter, we'd need to overcome the pull of this massive, invisible prison. Current estimates suggest an escape velocity from the Milky Way's center of about 550 kilometers per second, but from Earth's position it's still around 317 kilometers per second. Time itself becomes our enemy on intergalactic scales. The universe is 13.8 billion years old, but it won't last forever in a state that supports life. In about 1 trillion years, star formation will cease. In 100 trillion years, the last stars will die. Black holes will dominate, slowly evaporating through Hawking radiation over timescales that dwarf everything that came before. Even if we could travel between galaxies, we're racing against cosmic time and losing. Let's talk about the local group merger that's already sealed our fate. The Milky Way and Andromeda are rushing toward each other at 110 kilometers per second. In about 4.5 billion years, they'll collide and merge into a single elliptical galaxy, sometimes called Milkdromeda. This might seem like it makes intergalactic travel easier. Andromeda is coming to us. But the merger will gravitationally bind us even more tightly to our local region, creating an even deeper gravity well to escape from. The cosmic web structure of the universe presents another barrier. Galaxies aren't randomly distributed, they form filaments and walls separated by vast voids. These voids are expanding faster than the filaments, gradually disconnecting different regions of the universe. Even if we could somehow reach another galaxy, we might find ourselves trapped in another island cluster, with other regions having become unreachable during our journey. Radiation becomes lethal at relativistic speeds. As you approach light speed, cosmic microwave background radiation blue shifts into deadly gamma rays. Interstellar hydrogen atoms hit like radiation from a particle accelerator. At 99.9% light speed, the radiation exposure would kill any biological organism instantly. We'd need shielding so massive it would make acceleration to these speeds even more impossible. Physics doesn't just make intergalactic travel hard, it makes it deadly. Communication across intergalactic distances would be impossible for any meaningful purpose. A radio signal to Andromeda would take 2.5 million years to arrive. A conversation would span 5 million years per exchange. By the time you received a reply, entire species would have evolved and gone extinct. Even within our galaxy, communication with the far side takes 100,000 years round trip. We're not just physically isolated, we're informationally isolated too. The expansion of space creates an ultimate deadline. In about 100 billion years, all galaxies outside our local group will have vanished beyond the cosmic event horizon. Future civilizations will see a universe containing only Milkdromeda, surrounded by absolute darkness. They'll have no way to know other galaxies ever existed. If we don't escape in the next few billion years, which physics suggests is impossible anyway, our descendants will be forever locked in an island universe, with the rest of cosmos having literally disappeared from reality. Consider what we'd need for a generation ship to another galaxy. At 1% light speed, reaching Andromeda would take 250 million years. You'd need a self-sustaining ecosystem that could last longer than complex life has existed on Earth. The ship would need to maintain technology, culture, and purpose across 10 million generations. Genetic diversity would be lost. Language would evolve beyond recognition. The descendants arriving would share nothing with those who left except DNA, and even that would have changed significantly. The rocket equation delivers the mathematical death blow to our intergalactic dreams. Discovered by Konstantin Tsiolkovsky in 1897, it shows that the amount of fuel needed increases exponentially with desired velocity. To reach just 50% of light speed using perfect hydrogen fusion rockets, you'd need a fuel-to-payload ratio of about 1,000 to 1. For 90% light speed, it jumps to impossible numbers. You'd need planet-sized fuel tanks to move a small spacecraft to another galaxy. The universe has essentially written a mathematical proof that we're trapped. But it gets worse when you factor in deceleration. It's not enough to reach incredible speeds. You need to slow down at your destination. This doubles your fuel requirements, turning impossible into laughably impossible. Every equation we write, every calculation we perform, arrives at the same conclusion. The energy requirements exceed what's available to any civilization, no matter how advanced. We're not just limited by technology, we're limited by the fundamental relationship between mass, energy, and velocity. Wormholes, those darlings of science fiction, offer no real hope either. Yes, Einstein's equations permit their existence, but they'd require exotic matter with negative energy density, something that might not exist in the quantities needed. Even if we could create a wormhole, it would likely collapse instantly unless threaded with this hypothetical exotic matter. Recent calculations suggest that even microscopic wormholes would require the energy equivalent of a significant fraction of the Sun's mass to create and stabilize. The Alcubierre drive, proposed in 1994, seemed to offer hope by warping space itself rather than moving through it. But the energy requirements are absurd, originally calculated as more than the mass energy of the entire observable universe. Refinements have reduced this to merely the mass energy of Jupiter, but that's still impossible. Plus, recent studies show it would create causality paradoxes and might destroy itself through quantum effects. Every loophole physics seems to offer comes with fine print that makes it impossible. Let's examine what the James Webb Space Telescope has shown us about the early universe. We're seeing galaxies as they were over 13 billion years ago, watching the universe's youth. But here's the heartbreaking irony. We can see these ancient galaxies, study them in detail, but we can never, ever reach them. Most are already beyond the cosmic event horizon, their current locations receding faster than light. We're cosmic historians, able to observe, but never visit the universe's past. Dark energy's nature remains one of physics' greatest mysteries, but its effects are devastatingly clear. It's not just pushing galaxies apart, it's accelerating that push. Every cubic meter of empty space contains a tiny amount of dark energy, and as space expands, more space means more dark energy, means faster expansion. It's a runaway process that will eventually tear apart everything not bound by gravity or stronger forces. The universe isn't just making escape difficult, it's actively working to isolate every galaxy. The interstellar medium within our galaxy is already a hostile environment. Between stars, space contains about 1 atom per cubic centimeter, mostly hydrogen. This seems like nothing, but at relativistic speeds, these atoms become deadly projectiles. Now consider the intergalactic medium. It's 1,000 times less dense, but spans millions of light years. Any spacecraft would be sandblasted for eons, gradually eroded by individual atoms hitting with the force of bullets. Time dilation offers false hope. Yes, at 99.999% light speed, travelers could reach Andromeda in what feels like 25 years to them. But this is a one-way trip to the future. Earth would age 2.5 million years. Your civilization, your species, possibly all life on Earth would be gone. You haven't escaped the galaxy, you've escaped your entire timeline. It's not exploration, it's permanent exile from everything that defines you as human. The Fermi paradox takes on new meaning in this context. We wonder where all the aliens are, but perhaps they're exactly where we are, trapped in their own galaxies, looking out at a universe they can observe but never explore. The Great Silence might not be mysterious at all. It might be the inevitable result of cosmic expansion and the speed of light creating perfect prisons around every civilization that ever evolves. Our understanding of physics itself might be a barrier. We're trying to solve problems using rules discovered on one tiny planet. Perhaps there are aspects of physics we haven't discovered that make intergalactic travel possible. Or perhaps our current understanding is complete enough to definitively say it's impossible. Either way, we're gambling the future of human exploration on hope that physics has loopholes we haven't found. The merger with Andromeda won't be the violent collision you might imagine. Galaxies are mostly empty space. Stars almost never collide directly, but the gravitational disruption will be profound. Our solar system might be flung into a different orbit, possibly ejected into intergalactic space. Rather than enabling escape, the merger might trap us more thoroughly, creating a supergalaxy with an even deeper gravitational well and no nearby galaxies left to reach. Consider the philosophical implications. If we're forever trapped in the Milky Way, or at best the local group, what does that mean for humanity's future? We have perhaps a few billion stars we might someday reach, out of septillions in the observable universe. We're not just physically constrained, our potential for growth, for diversity, for survival against extinction events is fundamentally limited. The universe has given us a sandbox that seems enormous to us but is cosmically insignificant. The concept of the observable universe versus the actual universe adds another layer of cosmic imprisonment. We can only see objects whose light has had time to reach us since the Big Bang, a sphere about 93 billion light-years in diameter due to expansion. But the actual universe might be infinite. There could be an infinite number of galaxies we'll never see, let alone reach. We're not just trapped in our galaxy, we're trapped in a tiny bubble of observability within a potentially infinite cosmos. Energy considerations become laughable when you run real numbers. The total energy output of the Sun over its entire 10 billion-year lifetime wouldn't be enough to accelerate a decent-sized spacecraft to speeds necessary for intergalactic travel. We'd need to harness entire stars, maybe multiple stars, just to send single missions. The Kardashev scale, which measures civilizations by their energy usage, would need new categories. Even a Type civilization harnessing an entire galaxy's energy might struggle with intergalactic travel. Black holes, those cosmic monsters, offer no salvation either. Some theories suggested using black hole gravitational slingshots or extracting energy from their rotation. But getting close enough means dealing with tidal forces that would shred any spacecraft, radiation that would vaporize matter, and time dilation so extreme that millions of years would pass outside while you executed your maneuver. Black holes are cosmic prisons themselves, not keys to escape. The quantum vacuum might hold energy we could theoretically extract, vacuum fluctuations, zero-point energy. But the energy density is either impossibly small or impossibly large depending on your calculation method, and we have no idea how to extract it anyway. It's like dying of thirst in the ocean, surrounded by water you can't drink. The universe might be full of energy we can't access, taunting us with theoretical possibilities that remain forever out of reach. Let's talk about what happens to galaxies in the far future. In about 1 trillion years, all galaxies outside our local group will have faded from view, not because they've died, but because their light will be too redshifted to detect. Future astronomers will see only darkness beyond Milkdromeda. They'll have no way to know the universe ever contained other galaxies. If we don't escape soon, which we can't, our descendants will inherit a universe that appears to contain only one galaxy surrounded by infinite void. The biological challenges of intergalactic travel are insurmountable with known science. Human bodies evolved for Earth gravity, Earth radiation levels, Earth timescales. A journey of millions of years would require either suspended animation we can't achieve, generation ships that would fail over such timescales, or transforming humans into something that might survive but wouldn't be human anymore. We're not just physically unable to escape, we're biologically incompatible with the journey. Radiation damage accumulates over time. Even inside a shielded spacecraft, Cosmic rays gradually damage DNA, electronics, and materials. Over millions of years, this damage would be catastrophic. The spacecraft would literally decay during the journey. Metal would become brittle, seals would fail, electronics would malfunction. By the time you reached another galaxy, you'd be traveling in a dying ship, if it survived at all. The psychological and sociological barriers might be just as absolute as the physical ones. How do you maintain purpose and direction across 10 million generations? How do you prevent warfare, breakdown of society, loss of knowledge? History shows civilizations rarely last more than a few thousand years. Expecting one to survive millions of years in the confined space of a spacecraft isn't just optimistic. It's denying everything we know about human nature and social dynamics. Navigation becomes impossible on intergalactic scales. Stars we use for navigation would die and be born during the journey. Pulsars would spin down. Entire stellar populations would change. You'd need to constantly recalculate your position using references that keep disappearing. And if you get lost in intergalactic space, there's no recovery. You're in a void millions of light years from anything, with no way to reach safety before your resources run out. The local group itself is an island. Beyond it lies the Virgo supercluster, but even that's receding from us. In the far future, the local group will be alone in an observable universe, a single gravitationally bound system in an infinite dark. We're not just trapped in a galaxy, we're trapped in a small cluster that will eventually merge into one supergalaxy, surrounded by nothing. The universe is building walls around us, and those walls are made of expanding space itself. Computer simulations of the universe's future paint a depressing picture. As dark energy dominates, it will eventually overcome all forces except the strongest nuclear bonds. In about 22 billion years, dark energy might become so dominant it causes the Big Rip, tearing apart galaxies, solar systems, and eventually atoms themselves. We're not racing against just distance and energy, we're racing against the universe's own self-destruction. The anthropic principle suggests we observe these limits because universes without them couldn't support observers. Maybe faster-than-light travel would create paradoxes that prevent stable causality, making life impossible. We exist in a universe with these exact limitations because universes without them self-destruct. Our cosmic prison might be the price of existence itself. A universe that allows life must also trap that life within strict boundaries. The cold equations of thermodynamics deliver another blow to our intergalactic ambitions. The second law states that entropy always increases, and this has profound implications for long-duration space travel. Over millions of years, every system degrades. Perfect recycling is impossible. Energy is lost as waste heat. Materials degrade. Information corrupts. A journey to another galaxy isn't just fighting distance, it's fighting the fundamental tendency of the universe toward disorder and decay. Consider what we've learned from the Voyager missions. Launched in 1977, they're now in interstellar space and their power sources are failing. By 2025, we'll lose contact forever. These spacecraft, built with our best technology, are dying after less than 50 years. Now imagine maintaining a vessel for 50 million years. The engineering challenge isn't just building something that can travel between galaxies, it's building something that can survive longer than any material object has ever survived. The cosmic microwave background radiation, that faint echo of the Big Bang, will outlive all stars and galaxies. But even it's fading, cooling toward absolute zero. In about 10 to the 100th power years, even black holes will have evaporated. The universe is dying a slow heat death, and we're trapped inside watching it happen. Every second we delay makes intergalactic travel harder as galaxies recede and energy becomes scarcer. We're not just racing against distance, We're racing against entropy itself. Panspermia, the idea that life spreads between worlds, offers a different perspective on our imprisonment. If life can naturally spread between stars via meteorites or comets, why hasn't it spread between galaxies? The answer might be that intergalactic distances are simply too vast, the environment too hostile, the timescales too long. Even life itself, in its most basic and resilient forms, might be trapped within galaxies. We're not failing where others succeeded, we're hitting the same wall that stops everything. The multiverse hypothesis, if true, makes our situation even more poignant. There might be infinite universes with different physical laws, some allowing easy intergalactic travel. But we're stuck in this one. With these laws, these limitations, it's like being in a prison and learning that somewhere, in unreachable parallel realities, versions of us are free. The multiverse doesn't offer escape, it offers infinite variations of imprisonment. Let's examine what artificial intelligence and mind uploading might offer. If we can't send biological humans, perhaps we could send digital minds that don't age, don't need life support, don't care about million-year journeys. But this assumes we can create true AI or successfully upload consciousness, both unproven. And even digital beings need hardware that degrades, energy sources that fail, protection from radiation that damages circuits. The substrate changes, but the fundamental challenges remain. The Drake equation estimates the number of communicating civilizations in our galaxy, but there should be a modified version for intergalactic civilizations, and every term would be essentially zero. The distances are too vast, the energy requirements too high, the timescales too long. We're not just asking why we don't see aliens, we're understanding why we'll never see aliens from other galaxies. The universe has built perfect isolation chambers around every civilization. Quantum entanglements seem to offer hope for faster-than-light communication, but it doesn't work that way. You can't send information through entangled particles. Similarly, every exotic physics proposal, tachyons, cosmic strings, parallel dimensions, either doesn't exist or doesn't help. The universe seems carefully designed to prevent any loopholes. It's as if nature has thought of everything and closed every door we might use to escape. The sociology of extreme isolation would doom any intergalactic mission. Small populations suffer from genetic bottlenecks, cultural drift, and psychological breakdown. The minimum viable population for genetic diversity is around 10,000 individuals. Supporting them for millions of years requires resources we can't imagine providing, and that's assuming they don't destroy themselves through conflict, which human history suggests is wildly optimistic. We're not equipped, biologically, psychologically, or socially, for intergalactic isolation. Resource depletion within our galaxy might force us to look outward, but by then it'll be too late. If we consume the Milky Way's resources over billions of years, we'll have neither the materials nor the energy to attempt intergalactic travel. It's a cosmic catch-22. By the time we need to leave, we won't be able to. The galaxy that nurtured us will become our tomb, exhausted and unable to launch us toward new frontiers. The light horizon creates an ever-shrinking bubble of possibility. Right now, galaxies, about 16 billion light-years away, are at the edge of what we could theoretically reach traveling at light speed. But every second that horizon shrinks as expansion accelerates. In a billion years, it might be half that distance. We're not just stationary, we're effectively moving backward, watching the reachable universe shrink around us. It's cosmic claustrophobia on the grandest scale. Even our observations of other galaxies will eventually end. As they accelerate away and their light redshifts, they'll fade from view. First, we'll lose the ability to see their stars, then their brightest quasars, then any trace they exist. Future civilizations will inherit a universe that appears to contain only their local group. they'll have no way to know about the trillions of galaxies we can see today. Knowledge itself will be imprisoned by the same forces that trap our bodies. The fundamental forces themselves conspire against intergalactic travel. Gravity binds us to our galaxy. Electromagnetism limits our technology. The strong and weak nuclear forces constrain our energy sources. Every force we've discovered operates at light speed or slower. There's no force that enables faster than light anything. We're not just engineering limited, we're limited by the basic architecture of reality. The universe's operating system doesn't support the features we need for intergalactic travel. Consider the sheer emptiness of intergalactic space. Within our galaxy, stars are separated by a few light years. Between galaxies, we're talking millions of light years of almost perfect vacuum. It's emptier than the best vacuum we can create on Earth. A spacecraft would be more isolated than anything humans have ever experienced. No resources to gather, no landmarks to navigate by, no possibility of rescue or resupply. It's not just a journey, it's voluntary exile to the most desolate environment imaginable. The expansion rate, measured by the Hubble constant, is approximately 70 kilometers per second per megaparsec. This means for every 3.26 million light-years of distance, galaxies recede an additional 70 kilometers per second. By the time you've traveled partway to a distant galaxy, it's moved significantly farther away. You're not just chasing a moving target, you're chasing one that accelerates away from you. It's like running on a treadmill that speeds up the harder you run. Time becomes meaningless on intergalactic scales. Our entire recorded history spans about 5,000 years. The journey to Andromeda at realistic speeds would take 50,000 times longer. Language would evolve beyond recognition. The descendants arriving wouldn't be able to read the mission logs from departure. Culture, technology, even basic human nature would transform completely. The mission that arrives wouldn't be the mission that left in any meaningful sense. Let's examine the best-case scenario with physics-pushing technology. Assume we could build antimatter engines with perfect efficiency, achieving maybe 70% light speed. The journey to Andromeda would still take over 3 million years from Earth's perspective. During that time, our Sun will have noticeably evolved, Earth's continents will have shifted dramatically, and multiple ice ages will have come and gone. The civilization that sent the mission would be ancient history before it arrived. The cosmic web structure reveals another barrier. Galaxies cluster along filaments of dark matter separated by vast voids. These voids are expanding faster than the filaments, gradually disconnecting different regions. Even if we could reach another galaxy cluster, we'd just be in another prison cell with other clusters racing away. The universe isn't just big, it's structured in a way that maximizes isolation between regions. Stellar engineering, building megastructures like Dyson spheres, might seem like a path to gathering enough energy. But even harnessing our entire sun's output wouldn't provide enough energy for practical intergalactic travel. You'd need to consume multiple stars just to fuel one mission. The cure becomes worse than the disease, destroying our galaxy to escape it. It's like burning your house down to keep warm. The information paradox extends beyond black holes to intergalactic travel. Information can't travel faster than light, so any knowledge gained by intergalactic travelers is forever lost to their home civilization. They can't share discoveries, can't contribute to human knowledge, can't even confirm they survived. It's not exploration in any meaningful sense, it's permanent information death. The universe allows travel but forbids the sharing of what you learn. Gravitational waves, ripples in space-time itself, travel at light speed. Even cataclysmic events like colliding black holes can't send information faster. If the fabric of space itself respects the speed limit, what hope do we have of exceeding it? LIGO and Virgo have confirmed this precisely. gravity and light travel at the same cosmic speed limit. The universe's most fundamental phenomena obey the same restrictions that trap us. The false vacuum hypothesis adds existential dread to our imprisonment. Our universe might exist in a metastable state, like a ball perched on a hill. If true, it could decay to a lower energy state, destroying everything at light speed. This bubble of destruction would expand forever, eventually consuming the entire universe. We're not just trapped. We're trapped in a potentially doomed cosmos. Even successful intergalactic travel might just mean dying in a different galaxy when vacuum decay catches up. Evolution itself would work against intergalactic travelers. Over millions of years in the unique environment of a spacecraft or alien galaxy, humans would evolve into something else. Different gravity, radiation, diet, and selection pressures would create new species. The humans who arrived at another galaxy wouldn't be human anymore. We wouldn't be spreading humanity, we'd be creating isolated pockets of post-human species that could never reunite or even recognize each other. The philosophical implications are staggering. If we're forever trapped in our cosmic neighborhood, what's the purpose of intelligence? Why did the universe evolve consciousness capable of understanding its vastness if that consciousness can never explore it? We're like a child who can see the ocean but is forever forbidden from swimming. The universe shows us infinity, then locks us in a cage, its cosmic cruelty on an unimaginable scale. The Great Attractor, a gravitational anomaly pulling galaxies toward it at incredible speeds, demonstrates another aspect of our cosmic prison. Located about 250 million light-years away, it's already beyond our reach due to expansion. But it shows how the universe's large-scale structure creates currents and flows we're powerless to resist. We're not just trapped in our galaxy, we're being carried along by gravitational rivers we can't escape, toward destinations we'll never reach. Let me share something that truly drives home our isolation. The cosmic event horizon currently sits at about 16 billion light-years. But in just 1 billion years, it will shrink to only 5 billion light-years. In 10 billion years, only our local group will remain visible. The observable universe is literally shrinking around us. Every day, approximately 20,000 stars cross the horizon and become forever unreachable. We're watching the universe disappear, star by star, galaxy by galaxy. The energy density of dark energy is incredibly small, about 7 times 10 to the negative 30 grams per cubic centimeter. But because it's constant throughout space while matter dilutes as space expands, it inevitably dominates. In about 20 billion years, dark energy will comprise over 99% of the universe's energy. We're fighting an enemy that grows stronger with time, that feeds on the very expansion it causes. It's an unwinnable war against the fabric of space itself. Consider what we've learned from extremophiles on Earth. Life exists in boiling water, in acid, in nuclear reactors, in the deepest ocean trenches. But even the hardiest organisms can't survive the journey between galaxies. The combination of radiation, time, and absolute isolation exceeds any adaptation life has achieved. If evolution can't solve intergalactic travel after 4 billion years of trial and error, our technology won't solve it either. The Sloan Digital Sky Survey has mapped millions of galaxies, revealing the universe's structure in unprecedented detail. What it shows is heartbreaking, a cosmic web gradually tearing itself apart. The filaments connecting galaxy clusters are stretching, thinning, breaking. In the future, each cluster will be alone, surrounded by expanding darkness. We're not just isolated now. Isolation is the universe's final state. Everything tends toward absolute loneliness. Quantum mechanics offers no escape routes. Quantum tunneling allows particles to cross barriers they shouldn't classically overcome, but the probability decreases exponentially with distance. Tunneling across intergalactic distances would take longer than the universe's lifetime. Quantum entanglement can't carry information. Every quantum phenomenon we've discovered respects the same limits that trap us. The microverse offers no shortcuts through the macroverse. The metallicity problem reveals another barrier. Early universe stars contained only hydrogen and helium. Heavier elements needed for technology, carbon, oxygen, iron, came from stellar deaths over billions of years. Future stars will have different compositions as the universe evolves. Even if we could travel to distant galaxies, we might find environments where our technology can't function, where the basic chemistry of life as we know it is impossible. Time crystals, exotic states of matter that repeat in time rather than space, seem to offer new physics possibilities, but they still respect thermodynamics and causality. Every new phase of matter we discover, every exotic phenomenon we observe, operates within the same fundamental constraints. The universe keeps showing us new wonders that all obey the same prison rules. Innovation exists, but escape doesn't. The simulation hypothesis offers a different perspective on our limitations. If our universe is simulated, the speed of light might represent the maximum processing speed of the cosmic computer. Intergalactic distances might be deliberately impossible to traverse to reduce computational load. We might be trapped not by physics, but by design, isolated to make the simulation manageable. It's a prison built of code rather than space, but equally inescapable. Cultural and linguistic evolution would doom any multi-million-year journey. Languages change completely in just thousands of years. Over millions, even basic concepts would shift beyond recognition. The mission's purpose, recorded in languages no one understands, using concepts no one relates to, would be meaningless. You'd arrive at your destination with no idea why you came. The journey would erase its own meaning. The doomsday argument suggests intelligent life might be inherently self-limiting. Perhaps civilizations advanced enough to attempt intergalactic travel invariably destroy themselves first. Nuclear war, environmental collapse, artificial intelligence gone wrong. There are many ways to die, but few ways to survive millions of years. Our prison might be self-imposed, our limitations arising from our own nature rather than physics alone. Even our dreams of intergalactic travel might be symptoms of our imprisonment. We fantasize about escape because we're trapped. A truly free species wouldn't need to dream of distant galaxies. They'd already be there. Our science fiction, our space programs, our cosmic ambitions might all be psychological responses to subconsciously recognizing our cage. We're prisoners dreaming of freedom we'll never achieve. The universe's acceleration isn't constant, it's increasing. Dark energy's dominance grows with time, making expansion faster. This means the problem gets worse every second. The galaxies racing away today will be fleeing faster tomorrow. Every moment we delay makes escape more impossible. We're not just in prison, we're in a prison whose walls are closing in, whose bars are strengthening, whose locks are multiplying. The lithium problem in cosmology hints at how little we truly understand. Big Bang nuclear synthesis predicts 3 times more lithium-7 than we observe. If we can't accurately model what happened in the first minutes of the universe, how can we trust our predictions about intergalactic travel? Our prison might have aspects we haven't even discovered yet, barriers we can't see because our physics is incomplete. Ignorance compounds impossibility. Let's confront the ultimate irony. The same physics that allows us to exist also traps us. If the speed of light were infinite, causality would break down, making stable atoms impossible. If gravity were stronger, galaxies couldn't form. If dark energy were weaker, the universe would have already collapsed. We exist precisely because we're in a universe with these exact limitations. Our prison is the price of our existence. Freedom and being are mutually exclusive. The cosmic microwave background reveals the universe's baby picture, but it also shows our future isolation. As the universe expands and cools, this radiation will redshift beyond detectability. Future civilizations won't even have this evidence of the Big Bang. They'll theorize about origins without data we take for granted. Knowledge itself is temporary, and our descendants will be imprisoned in ignorance as well as space. Neutron stars demonstrate nature's extremes, but even they can't escape. These city-sized objects with the mass of suns, with gravity so strong that mountains can't exceed a few millimeters, are still bound to their galaxies. If objects with escape velocities of 1/3 light speed can't break free, what chance does fragile human technology have? The universe's strongest objects are still prisoners. The Hubble Ultra-Deep Field image, showing thousands of galaxies in a patch of sky the size of a grain of sand held at arm's length, reveals the true scope of what we're missing. Each dot represents billions of stars, trillions of planets, infinite possibilities, all forever beyond reach. We can photograph infinity but touch almost nothing. It's like showing a starving person a picture of a feast. The universe's cruelty is showing us what we can never have. Galactic collisions should offer hope. Galaxies do interact. But these are rare events between gravitationally bound neighbors. The Milky Way and Andromeda will merge because they're in the same cluster. But clusters themselves are racing apart. These collisions are like prisoners in the same cell block mingling. It doesn't mean escape from the prison. We're rearranging our confinement, not transcending it. The anthropic principle becomes a curse when applied to intergalactic travel. We observe these limitations because observers can only exist in universes with these limitations. There might be universes where intergalactic travel is easy, but they can't support observers to appreciate it. We're trapped in a cosmic catch-22. Existing means being imprisoned. Consciousness itself might require isolation. Dark matter's invisibility mocks our ambitions. Here's 6 times more stuff than we can see, and we can't even detect it directly, much less use it. It's like being in a cell where the walls are mostly invisible but just as solid. The universe hasn't just imprisoned us, it's hidden most of the prison from view. We're trapped by forces we can barely perceive in a cage we can't fully see. The fine-tuning problem reveals another layer. Physical constants seem precisely calibrated for life. Change any by tiny amounts and stars don't form, chemistry doesn't work, or the universe collapses. But this same fine-tuning that allows life also creates our limitations. The constants that permit atoms also forbid faster-than-light travel. We're not accidentally trapped, we're necessarily trapped. The universe couldn't support us without also constraining us. Consider the computational requirements for simulating intergalactic travel. Even planning a mission would require modeling millions of years of cosmic evolution, stellar positions, and gravitational interactions. The calculations would take longer than the journey. We can't even properly think about escape, much less achieve it. Our minds are as trapped as our bodies, limited by the same physics that limits our spacecraft. The many worlds interpretation of quantum mechanics suggests every possible outcome occurs in parallel universes. Somewhere, versions of humanity have attempted intergalactic travel. They've all failed or are still traveling, forever isolated from all other branches. Even in infinite universes with infinite attempts, success requires communication back home to matter. Without that, every branch remains equally trapped, equally alone. Stellar archaeology tells us about the universe's history through the composition of ancient stars, but it also reveals our future, a universe gradually running out of the heavy elements needed for technology and life. Star formation will slow, then stop. The universe will become increasingly hostile to complexity. We're not just racing against expanding space, but against the universe's slide toward simplicity and death. The cosmic censorship hypothesis suggests nature hides its breaking points behind event horizons. Maybe the universe prevents intergalactic travel because allowing it would break something fundamental. Perhaps isolation is necessary for consistency, and any loophole would unravel reality itself. We're not trapped by arbitrary rules, but by the requirements of existence. The prison is the price of having a universe at all. The vacuum catastrophe, the 120 order of magnitude discrepancy between predicted and observed vacuum energy, shows how profoundly we misunderstand empty space. If our theories are that wrong about vacuum, how can we trust them about intergalactic travel? The very medium we travel through is a mystery. We're trying to escape a prison we don't even comprehend, using physics that fails at fundamental levels. Let's face the psychological reality. Humans evolved for immediate environments, short timescales, small groups. A million-year journey violates every psychological need we have. The crew would go insane long before reaching another galaxy. Generations would be born into a purposeless existence, living and dying for a mission they didn't choose and won't complete. It's not just physically impossible, it's psychologically impossible. We're the wrong species for intergalactic travel. The Lyman alpha forest, absorption lines in quasar spectra, from intergalactic hydrogen, maps the universe's structure but also reveals our cage's bars. These clouds of gas between galaxies would erode any spacecraft over millions of years. Even empty intergalactic space is an obstacle course of invisible barriers. The universe hasn't just made the journey long, it's made the path hostile. We're not just far from other galaxies, we're separated by an actively dangerous medium. Time itself might be emergent rather than fundamental, arising from quantum entanglement according to some theories. If time isn't basic to reality, our concepts of journeys and duration might be meaningless at fundamental levels. We might be imprisoned not in space but in our perception of time. The journey to another galaxy might be impossible because journey itself is a flawed concept at cosmic scales. The black hole information paradox remains unsolved, showing gaps in our understanding of fundamental physics. If we don't know what happens to information falling into black holes, how can we claim to understand intergalactic travel? Every unsolved problem in physics might hide another barrier we haven't discovered. Our known impossibilities might be joined by unknown ones even more absolute. Consider the energetics of communication. Even if we could travel to another galaxy, sending information back would require impossibly powerful transmitters. The inverse square law means signals weaken with distance squared. From Andromeda, you'd need the power of stars just to send detectable signals to the Milky Way. Exploration without communication isn't really exploration, it's just elaborate suicide. The universe allows travel but forbids sharing what you find. The cosmic neutrino background, relic neutrinos from 1 second after the Big Bang, passes through everything barely interacting. These particles have traveled for 13.8 billion years without being absorbed. If neutrinos, the universe's ultimate travelers, take billions of years to cross cosmic distances, what hope do complex spacecraft have? Even nature's simplest travelers can't escape in reasonable time. Galactic habitability zones suggest most of our galaxy is hostile to life. Too close to the center means excessive radiation and gravitational disruption. Too far out lacks heavy elements. The habitable zone is a narrow ring, further limiting our options. We're not just trapped in a galaxy, we're trapped in a small portion of it. Our prison has a prison inside it, constraints within constraints. The measurement problem in quantum mechanics, how possibilities become realities, might extend to cosmic scales. Perhaps the universe prevents intergalactic travel because observing other galaxies up close would collapse some cosmic wave function in catastrophic ways. We might be quarantined not by distance but by quantum mechanics, isolated to preserve reality's coherence. Observation has limits, and those limits might include proximity. Plasma cosmology, though largely discredited, raised important questions about electromagnetic forces on cosmic scales. Even if wrong about the universe's structure, it highlighted how much we don't understand about intergalactic magnetic fields. These fields might create barriers we haven't imagined, channels and walls of force that constrain possible paths between galaxies. The universe might be more maze than open space. The Copernican principle says we're not special, but our isolation suggests otherwise. If intelligence is common, why don't we see intergalactic civilizations? Either we're alone, or everyone is trapped like us. Both options are profound. We're either unique in a sterile universe, or typical in a universe of prisons. Neither offers hope for escape. The principle that demoted Earth from the center might also confirm our permanent imprisonment. Vacuum decay could propagate at light speed, meaning if it started anywhere in our past light cone, we're already doomed. This creates an additional time pressure, not just racing against expansion, but against potential cosmic catastrophe. Every second might be borrowed time. The universe might not give us millions of years to develop intergalactic travel. Our prison might have an execution date we can't see coming. The holographic principle suggests our three-dimensional reality might be encoded on a two-dimensional surface. If true, what we perceive as vast intergalactic distances might be illusions of a deeper reality where everything is much closer or much farther. We might be trying to travel through dimensions that don't fundamentally exist. Our prison might be perceptual, trapped by assuming space is what it appears to be. As we reach the end of this cosmic journey, let's confront the ultimate truth. The universe has constructed the perfect prison. It's not made of walls or bars, but of space itself, expanding faster than we can ever travel. It's not guarded by wardens, but by the laws of physics, immutable and absolute. Every scientific discovery, every telescope observation, every equation we solve doesn't show us escape routes. It reveals more locks on our cage. We're not finding solutions. We're finding more elaborate explanations for why escape is impossible. But here's what makes this profound rather than just depressing. We've figured this out. Beings made of carbon and water living on a tiny rock have deduced the architecture of their own prison. We've measured distances we can't travel, understood forces we can't overcome, discovered our own limitations with stunning precision. The fact that we know we're trapped is itself a kind of transcendence. We're prisoners who understand the engineering of our jail. The James Webb Space Telescope shows us galaxies from 13 billion years ago, their light just reaching us now. We're seeing these galaxies as babies while they're already ancient or dead. By the time we see them, they're already beyond reach, racing away faster than light. We're not exploring the universe, we're watching its history, cosmic archaeologists studying ruins we can never visit. Every discovery is a goodbye, every observation a farewell to something we'll never touch. Consider what this means for humanity's future. We have perhaps 1 billion years before Earth becomes uninhabitable as the sun brightens. A few billion more before the sun dies. If we survive, we might spread throughout the Milky Way, colonizing perhaps a few billion stars. But that's it. That's our maximum extent. We're not destined for the universe. We're destined for one galaxy among trillions, and eventually not even that. Our cosmic story has a maximum size, a boundary we can calculate but never cross. The Fermi paradox resolves into something even more disturbing than being alone. We might be surrounded by intelligence, each species trapped in their own galaxy, all looking out at the same unreachable cosmos. The universe might be full of civilizations, all reaching the same conclusion we're reaching now, that the stars they see are forever beyond reach. We're not alone in the universe. We're alone together, each in solitary confinement, able to see each other's prisons but never meet. Yet within our galactic prison, wonders await. There are 200 billion stars in the Milky Way, likely trillions of planets. There are stellar nurseries where new stars are born, ancient globular clusters that remember the universe's youth, supermassive black holes that warp space-time into fantastic geometries. We're trapped, yes, but in a cage so vast and complex we could explore for millions of years without seeing it all. Our prison is magnificent, even if it's still a prison. The local group will eventually merge into one giant elliptical galaxy, Milky. This will be humanity's final home if we survive that long. One galaxy containing perhaps 1 trillion stars, surrounded by absolute darkness, as all other galaxies vanish beyond the cosmic horizon. Future civilizations won't even know other galaxies existed. They'll develop cosmologies where the universe is one galaxy floating in an infinite void. Their physics textbooks won't mention galaxy clusters or cosmic expansion because they'll have no evidence these things exist. Dark energy guarantees our isolation becomes absolute. It's not enough that we can't reach other galaxies. Eventually, we won't even see them. The universe is erasing evidence of its own vastness. In 100 billion years, the cosmic microwave background will be undetectable. The universe will have hidden its own origin story. We live in a brief cosmic moment when the universe's history is still visible. We're trapped, but at least we can see what we're trapped away from. Our descendants won't even have that. The meaning of existence changes when you realize escape is impossible. We're not a species destined to inherit the universe. We're a local phenomenon confined to a tiny fraction of space and time. Every human who will ever live will exist within this one galaxy or its merger remnant. Every thought, every achievement, every work of art, all confined to this cosmic island. We're not writing a story that spans the universe. We're a footnote in one galaxy's history. But maybe that's enough. Maybe meaning doesn't require cosmic scope. We're arrangements of atoms that have become aware of atoms. We're the universe looking at itself, even if only from one limited viewpoint. Our imprisonment doesn't diminish the beauty we can perceive, the knowledge we can gain, the experiences we can share. We're trapped in the Milky Way, but the Milky Way is magnificent. We're prisoners, but we're prisoners in paradise, at least for now. The death of the universe, heat death in about 10 to the 100th power years, means nothing escapes ultimately. Whether trapped in one galaxy or free to roam, everything faces the same final fate. Perhaps our intergalactic imprisonment doesn't matter on cosmic timescales. Whether we die in the Milky Way or Andromeda or some distant galaxy, we still die. The universe itself is temporary, making our spatial limitations almost irrelevant against temporal ones. Our cosmic story isn't about escape, it's about making the most of where we are. We have billions of stars to explore, countless worlds to discover, mysteries within our galaxy that could occupy us for eons. The Milky Way is our inheritance, our domain, our only home. Instead of mourning the galaxies we'll never reach, perhaps we should celebrate the galaxy we have. It's more than any species could fully explore, more than enough for any civilization's ambitions. So yes, humanity will probably never escape the Milky Way. The distances are too vast, the expansion too fast, the energy requirements too impossible. We're trapped by physics, by time, by the fundamental architecture of reality. But we're trapped in a galaxy with hundreds of billions of stars, likely trillions of planets, and wonders we've barely begun to discover. Our prison is so large it might as well be infinite from any practical perspective. This is our cosmic situation, eternal prisoners who understand our imprisonment, trapped in magnificence, isolated in abundance. We'll never touch most of the universe, but we can understand it. We'll never escape our galaxy, but we might not need to. The Milky Way is enough space, enough time, enough wonder for any species. Our tragedy is also our opportunity. Our prison is also our playground. Our limitation is also our home. Thank you for joining me on this journey to the edges of possibility and back. If this exploration of our cosmic imprisonment has changed how you see our place in the universe, please share this video with someone who looks at the stars and wonders. Subscribe to continue exploring the profound limitations and incredible possibilities of our cosmic situation. Remember, we might be trapped in the Milky Way, but that still makes us citizens of 100 billion stars. The universe has imprisoned us in grandeur. What other cosmic limitations should we explore? What other beautiful prisons has the universe constructed? Leave your thoughts below, and let's continue to map the boundaries of our magnificent cage together. Until next time, keep looking up at the stars, even knowing you'll never reach most of them. Sometimes understanding our limits is the first step toward finding meaning within them. If you are still watching, make sure to subscribe to the channel and give a thumbs up. And if you want to keep exploring the mysteries of the universe, I'm sure you will love this other video at the left side of the screen. Will we ever leave our solar system? In this video, we explore the science, technology, and human challenges behind interstellar travel, humanity's quest to reach the stars, and much more. See you there. Thanks for watching.